Welcome back. Today we're going to talk about polynomial division. This is section 3.3, and polynomial division is useful for finding zeros of functions of higher degree. And so by dividing, we're going to come up with a smaller polynomial so that it might be easier to factor, or we might pull out some factors that allow us to find zeros. So let's look at how we do it. We're going to do two different things today. We're going to do polynomial division. We're also going to do synthetic division. Both of them have the same aim, and polynomial division is kind of the long division of polynomials. So let's get right into it. In order to divide polynomials, we need to set them up like we would in long division. And so I'm going to write what I'm dividing. Okay? And it's going to go inside the house. And so if we're dividing by something, this is what would be on the bottom of the fraction. So like 6x cubed minus 19x squared plus 16x minus 4 would be on top. This would be on bottom. Well, the way to think about it is what's on bottom kind of is the horse. The horse stays outside of the house. The cowboy that rides on top, what's being divided, goes inside the house. And so as I'm starting this process, I'm starting from the front here, okay? And so 6x cubed is what I'm dividing, and I'm looking at my lead term here, my x. My question is, what do I have to multiply x by to get 6x cubed? And so what I'm going to do is, I am going to say, I'm multiplying it by 6x squared. Now, why does it go here and not here? Well, I'm keeping everything in columns here. So my x squared terms are going to go over my x squared, my x terms are going to go over my x, my constant terms are going to go over my constant. And so I'm trying to divide each term, the 6x cubed, then the 19x squared, then the 16x, then the 4, by what we've got here, you know. But what's going to happen is I'm going to start bringing down all of my answers as I come. So these are actually going to change as I go along. So you'll see how it works. So in this case, now I'm going to multiply around. So 6x squared times x would be 6x cubed. And then 6x squared times minus 2 would be minus 12x squared. And so you can see I started putting my answer here in the line with the x squared column, but as I multiply, I'm going to put it underneath where it needs to go, because as I subtract, now 6x cubed minus 6x cubed is 0. So I have no more x cubed terms. I'm subtracting a minus 12x squared, so that'd be plus 12x squared. So this would be minus 7x squared, because I'm subtracting negative 12x. And then I'm going to bring down my 16x. This is my new term that I'm looking at. And so I'm asking myself, what do I multiply x by to get minus 7x squared? And so the answer is minus 7x, because minus 7x times x would be minus 7x squared. So I'm trying to get this term, as I bring them down, I'm trying to get this one by multiplying my lead term there. Then I'll do minus 7x times minus 2 would be plus 14x. And I just realized I forgot to bring down my x with my 16. Again, I subtract. And this should look very familiar to regular long division. And so when I subtract minus 7x squared minus a minus 7x squared, that will be plus. And so I get a 0. That's good. 16x minus 14x would be 2x. Now I'm going to bring down my minus 4. And this is my new term that I'm looking at, my 2x here. And what do I have to multiply my x by to get 2x? The answer is positive 2. So 2 times x would be 2x. 2 times negative 2 would be minus 4. And when I subtract, this is really good, because 2x minus 2x is 0, and negative 4 minus a negative 4 would be 0, and so there is no remainder. So it evenly divides. So what is 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2? The answer is 6x squared minus 7x plus 2. Okay, so this is an algorithm, meaning it's a formula that we repeat it over and over. This is how we do it. So we're going to keep going and doing what multiplies by the lead term here, the x, to get what I'm looking for. Let's do another example, and I think you'll see it come together more. In the last example, you notice that I had a bunch of terms. Well, now I've got less terms, and so I need to make sure I'm writing this correctly. Well, one of the keys to look out for is I need to write this with all degrees of terms. And you're going to see what that means when I rewrite this. So I'm going to start off by putting it under the house, because remember that's what would be on top. So x to the third minus 1 divided by x minus 1. The x to the third minus 1 will be the cowboy. It goes inside the house. And to write with all degrees of terms, I don't have an x squared term, and I don't have an x term, but I have to account for them. And so I'm actually going to write it as a big long polynomial with all of the degrees of terms. So my highest degree term is x to the third. I have to write in my x squared, I have to write in my x, and then I've got my 1. And you're going to see why it has to happen like this in just a minute. Because as I divide, I'm looking at the x cubed. What do I multiply x cubed by, or x to get x cubed? Well, it's going to be an x squared. So I'm looking at the x cubed. What do I multiply x by to get x cubed? Well, it's x squared. Well, if I didn't have that x squared column there, I'd have nowhere to put it. So I got to multiply that by x squared. So now as I multiply and subtract, x squared times x is x cubed. X squared times minus 1 will be minus x squared. I subtract. This gives me 0. Subtracting a negative gives me positive x squared. I'm bringing down my 0x. So now I'm looking at my x squared term. My x squared term, what do I multiply x by to get x squared? Well, it's a positive x, so I'm going to have x squared here. And then x times minus 1 will be minus x. And I'm going to subtract, so I get 0, and this becomes a positive x. Continue my process, bring down my minus 1. So what do I have to multiply x by to get x? It's 1. So 1 times x would be x. 1 times minus 1 would be minus 1. And when I subtract, I get 0 and 0. So no remainder here. And this is good, no remainder. So it divides evenly in. This is perfect, perfect situation. Let's do one that's got a remainder so you can see how this works. We're going to go through this process. So this is what would be on top. This is what would be on bottom. So I'm going to go 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2. And I'm going this way. On the outside, I got x squared plus 2x minus 3. And so what you're going to see is we are dealing with some higher degree polynomials here. So not only do I have the fourth, but I've also got, on the outside, I've got a trinomial now. Struggling with the writing here. It's all good. Okay, so now my process is still the same. I'm looking at my first term. What do I have to multiply x squared by to get 2x to the fourth? Okay, so the answer is 2x squared. And I'm making sure to keep it in line with my x squared columns. That's okay that I don't have two of them aren't full here. That's all right. So I've got 2x squared times x squared would be 2x to the fourth. 2x squared times positive 2x would be 4x to the third. 2x squared times minus 3 would be minus 6x squared. And as I go to subtract, I've got 0. I've got 0. That's cool. That was a 2 for 1 special there. And as I subtract a negative 6x squared, I end up with an x squared. Okay, so this is all right. I'm going to bring down my plus 3x. And so I'm looking at my x squared. What do I have to multiply my lead term here, my x squared by to get x squared? Well, I got to multiply it by x, or sorry, I got to multiply it by one. Well, that's weird. I'm not multiplying it by an x. I'm multiplying it by a 1. And so I'm going to actually skip over this term. So I don't need an x term. Like I have an x squared here and an x squared here. So I just need to multiply that by 1 to get me what I want. So I'm actually just going to skip over this plus 0x plus 1. So that's a possibility. If you don't have to multiply by an x to get this term, that's okay. And so 1 times x squared would be x squared. 1 times 2x would be 2x. And 1 times minus 3 would be minus 3. Well, what do I do with this column? I got to bring down my minus 2. So I'm going to subtract. And this comes out to 0. This comes out to x minus, so 3x minus 2x is x. And then negative 2 minus a minus 3 would be plus 1. Okay? Notice I'm out of spots here, and there's nothing I can multiply by to get x. So I've got the x squared, there's nothing I can multiply by. So this is actually a remainder. This is a remainder. And so as a remainder, what's my answer? My answer is 2x squared plus 1 plus my remainder over what I was dividing by. Because remember, the remainder is really just saying I did this whole division problem, divided this polynomial by this polynomial. And so my remainder has to go over that original polynomial. So x squared plus 2x minus 3. And so a remainder just gets written as a fraction on the end. So this is my answer to my problem. Okay, use that remainder to come up with a fraction on the end of that polynomial. Okay, it's a process, guys. Keep asking that question. What do I multiply my original by to get what I've brought down in my problem? Okay, that's polynomial division. We're going to do synthetic division in a separate video. So thanks for watching, and we'll see you next time.